How many of you have ever done any digital voice? Anybody? D-Star? DMR? Fusion? P25? NXDN? M17? Okay, so about half of you are experienced, half of you are not. So the first thing I want to talk about is the difference between analog versus digital. Analog is what we have on, let's say, the 14679 repeater. Traditional analog FM radio, okay? A lot of people think that the voice over IP modes are digital, like Echolink, All-Star, IRLP. Those are not digital modes. Those are analog modes that are using voice over IP to convey the voice data. So what we're going to talk about tonight is digital voice. Digital voice is where it takes your voice and converts it to a digital mode, be it D-Star, be it DMR, be it C4FM. Those are the primary ones that we're going to talk about, and then transmits it out over the radio, over the network, if it's a network connected system, back to another radio. The major digital voice modes for amateur radio are D-Star. D-Star is the oldest mode. Radio manufacturers from ICOM and Kenwood make D-Star radios. DMR originally was a commercial technology for commercial radios. It's been bastardized by amateur radio. DMR radios, there's no current real traditional amateur radio manufacturer like Yaesu, Kenwood, ICOM that makes a DMR radio. So for a DMR radio, you need a Motorola, Itera, some commercial radio, Titera, or the cheap Chinese radios. C4FM, Yaesu Fusion. The only manufacturer of Yaesu C4FM Fusion radios is Yaesu. P25, again, is another commercial technology. For P25, again, none of the amateur radio manufacturers are manufacturing it. So you need to get a commercial radio. Most of them are made by Motorola, Kenwood, or Harris. NXDN, again, another commercial technology made by ICOM and Kenwood. And M17 is the newest digital voice technology that's being created by amateur radio operators. And at this point in time, there is no manufacturer that's making a radio for it. There's some projects that will take a traditional DMR radio and convert it with software and hardware to be able to make it to be used for M17. Why would you use digital voice over analog? Well, the first of all is that you don't have the static, the noise that you have traditionally. In other words, if I'm talking to Tom and he's down over the hill on 16 going towards Glencoe and he drops out of the 14679 repeater, I'll be listening to him, and the static and the noise will ultimately overtake his voice and I won't be able to hear him anymore. If that was a digital signal that he was talking to, he would either be there or not. There would be no noise. There may be some artifact. We call it R2D2 in the digital voice mode world, but it's either there or it's not there. It's either a crystal clear signal or it's no longer copyable at all. The coverage footprint area. It's alleged that the coverage footprint area of a digital signal is greater than that of an analog signal. Now, there's a lot of controversy to that. I guess the one time that I think that it is with DMR. There's a repeater in Edgewood, Kentucky that sits on the club's Edgewood tower site, or at the club's Edgewood tower site. K4TCD is a DMR repeater. Prior to that was where the club's 444.350 analog repeater was. For years, I live in Big Bone, for those of you that don't know, and at Hathaway Road with a 45 or 50 watt mobile radio on UHF with an outside 5/8 wave antenna, I would have trouble getting into that analog repeater in Edgewood on Hathaway Road. We took that analog repeater down and the DMR repeater was installed. I was using a cheap Chinese $100 TYT DMR handheld inside my car, no outside antenna, and could carry on a conversation as I traveled out on Hathaway Road and was able to be heard. So there is some evidence to indicate that it does have a larger footprint. The guy that got me involved in digital voice is a guy by the name of John Donnelly, KY4JD is a silent key. And John and Roger, KY4RS, who was into D-Star before I was into D-Star, have had a simplex QSO on 2 meters on D-Star, where I was at my house in Big Bone. Roger was at his condo in Triple Crown, and John was at his house in Fort Wright, and we could not hear each other on simplex FM, but could carry on a conversation on D-Star simplex. So there is some evidence to indicate that it might have a bigger footprint. You don't have the noise is a big thing.
There is some controversy against that from people who buy.
Yeah, there's controversy against that everywhere as far as all the digital modes. I have been involved in a group that take and do HF D-Star. And it's been our experience from the years of doing that. KQ4KK is the guy that started that whole process. There's a net every Saturday night at 7 p.m. and Sunday morning at 10 p.m. Where guys get on all over the country on D-Star HF, which is one of the few modes that will do digital voice on HF, and they'll conduct surveys. And pretty well the conclusion is you can get through on single sideband a lot more than you can on D-Star. So again, there's a lot of controversy. I don't want to mislead you in any form or fashion. One of the big advantages is the network-wide area systems. Systems are linked. Because it's digital voice, it goes into a main system. And we're going to talk about those networks here in a little bit to provide worldwide coverage with a handheld radio. The other is the idea of hotspots versus repeaters, and this was the draw for me. At the time when John was trying to get me into D-Star, I was still working. I worked in Burlington. My office was essentially a Faraday cage. You couldn't get any radio signals out of the building or in the building. I live in Big Bone. It's a really big challenge to try to hit a repeater in the greater Cincinnati area. Because even though my house sits on top of a hill at 700 feet in elevation, a 1.25 miles northeast of me is Big Bone Baptist Church, which sits on a ridge at 820 feet in elevation. So I got 125 feet of dirt between me and the Cincinnati area, and then another 1.5 miles further up is the Hathaway Road Ridge, or Mount Zion Road Ridge, which generally runs around 900 feet in elevation. So I got 200 feet of dirt between me and greater Cincinnati or Cincinnati or northern Kentucky. So it's a real challenge for me to get a signal out. So the whole concept of some way to be able to do it came into play. And a guy by the name of Robin Crushaw developed a concept called reflectors and a device called a DVAP, a digital voice access point. And we'll have a picture of it here later on because I still got some of them and use them today. This was a device that he created that essentially was a simplex UHF repeater that would connect by USB to a computer, and you could run some software, and you could take a handheld radio, transmit, it would go to this little device that was connected to a computer, it would receive that, put that into the network over the internet, and be able to talk to anybody anywhere around the world. And at that point in time, I was sold because I bought myself an ICOM ID92 handheld. I bought one of the DVAPs, and I'd go to work and I'd plug that thing into a computer at work, and I'd sit there and I'd listen to people all over the world on my little handheld radio while I was working all day. I'd come home, I'd stick it into a computer at home, and I could do the same thing and communicate all over. So you have hotspots, which was the big advantage of me, or repeaters. And we're going to talk about the difference between those. A repeater, we're all familiar with a repeater, the 146.79 repeater. In other words, what it does for those that aren't knowledgeable about repeaters, a repeater receives on the transmit signal of your radio. For example, the 146.79 repeater, when you key up that mic, your radio is transmitting on 146.19. The repeater hears it and immediately transmits it back out on 146.79. Now, why does it do that? Well, because you got a handheld. If you were talking handheld to handheld, if I'm talking to Mike in Fort Thomas and I'm a handheld in Big Bone, he's not going to hear me. But if my handheld can get to that repeater, 146.79's in Taylor Mill on the top of the Mobilecom tower, and it's retransmitted out, but I can hear everything that's from the Mobilecom tower in Taylor Mill, everything within that area will hear my transmitted signal. So it improves the footprint of where you can communicate. It's used by many operators on analog system, and in this case, digital voice is used by many operators as well. And the system is controlled by the repeater owner. Now, with an analog repeater like the 146.79, anybody that keys up an analog signal with the proper PL tone is going to get into the repeater. However, digital works much differently. You got to have a secret code, and depending on what digital mode it is as to whether you can get into the repeater. So it can be controlled by the repeater owner and your radio. A hotspot, and I have a number of hotspots here that I have set up, and also a number of radios that are set up. You provide the internet connection. So you have that hotspot. Essentially, these hotspots right here, this one here is an open spot 2. This black thing is a battery. It's on a particular frequency. I can talk on a radio that will transmit to this little device. This little device is communicating by Wi-Fi to my Verizon MiFi hotspot, which provides the internet connection for the communication. So I can hear whatever's going on anywhere in the world wherever I put that hotspot. And I can use my handheld radio to communicate to this device that's then connected by Wi-Fi to this device that's connected to the internet through Verizon's internet system and talk to anybody else anywhere in the world. It covers a small area, obviously. The transmitter, receiver, and the antenna are all contained in this little white thing. This is a Raspberry Pi based hotspot. You can see the antenna on it. The board on top is a radio board. The board underneath is a Raspberry Pi Zero that communicates. Again, what's the range of this device? Well, it gets me anywhere on my property in Big Bone with a handheld. But further than that, it's not going to provide the big footprint that a repeater will have. But it's connected to the internet, and it provides the ability to talk anywhere in the world on whatever system you have it set up on. Most of these are simplex operation. In other words, your handheld radio transmits on one frequency and receives on the same frequency. So when I key up, it goes to this. This is listening to my transmission. When I unkey, then this transmits and sends the information back to the handheld. There's a number of options and types of hotspots available. These are some pictures of some of the hotspots that I have. I've shown you the open spots, which are these. There's open spot 1, 2, 3, and 4. I've got some of each of them. This is an open spot 3 here in the picture. This is an open spot 2. The original DVAP that I told you about, it only works on, and the open spots will work on all the digital voice modes for amateur radio. The one in the right-hand corner here, this little red thing, and then there's a Raspberry Pi 3B that's behind it. It's plugged into the 3B. That's the original digital voice access point that was created by Robin Crusaw, which only does D-Star, because that was all that was developed at the time. And that still works for D-Star as good today as it ever did. I've got it plugged into a Raspberry Pi there, running some software on Raspberry Pi that enables me to utilize that as a hotspot. This one here is what's called a jumbo spot. It's it's essentially the same as this one here, only it's in a different case. Those are cheap Chinese MMDVM boards that are thrown on a Raspberry Pi and right now run a version of what's called Pi Star, which essentially is just an overlay dashboard of G4KLX, a British guy that designed the real meat and potatoes of all these Raspberry Pi-based hotspot. It's the working part of it is the G4KLX software. This here is a Zoom spot, which originally was the original Raspberry Pi-based small MMDVM board, but then was counterfeited by the Chinese for the jumbo spots and the other stuff like everything else. And I have one of those.
The jumbo spots are really budget friendly, but the CPU gets really
Hot, yeah. This is again a jumbo spot taken with the cover off of it. So you can see there's the Raspberry Pi Zero, the radio board, and this one has a screen on the top of it. Some of them have screens, some of them don't. This one, I think this one that I have with me does not have a screen. It just has the radio board and the Raspberry Pi. This is an older hotspot. It was between the DVAP and the MMDVM boards. It runs on a Raspberry Pi with a plug-in board that was much larger that was called a DV Mega board. And those still operate. You updated the firmware and it would do all the different modes. So the only hotspot that is specific to a particular digital voice mode in these pictures of these 6 hotspots is the DVAP, and it only runs on D-Star. It doesn't do any of the other digital voice modes. Each one of these, like everything else in life, have their own strengths and weaknesses. There's good things and bad things about each of them, pluses and minuses. Some people like the Raspberry Pi-based hotspots. Some people like the open spots, which are made by RF Shark in Estonia. And there's a ton of different flavors of the Raspberry Pi-based hotspot. And there's a lot of companies that will sell you a commercial Raspberry Pi-based hotspot, which is really the same as everybody else's, but they'll tell you and sell you that it's something altogether different. Now, there also is a 2 radio or a dual radio hotspot I'll show you a picture of later on that works very, very well with DMR, which again is a slightly different wrinkle, but again runs the same G4KLX based Pi Star or W0CHP based fork of Pi Star to be able to control it. Repeaters versus hotspots. Again, it's all about the control, and you'll hear me continue to talk about that as we go through the different modes of operation, and you're trying to struggle with, do I want D-Star, do I want DMR, do I want Fusion, or are you addicted like I am and do everything? Repeaters, the rules are set by the repeater owner. In other words, if you're a repeater owner, you set up the rules. You set up where it's going to connect to and how it's going to connect. You know, it's your repeater. That's how you control it. Access is controlled by the repeater owner and perhaps the network it's connected to. And we'll talk about the differences of that here in a little bit. Repeaters, again, like we said before, have generally a large coverage area, but there's other owners on the repeater. So in other words, and this is primarily an issue with DMR, because you have these time slots that we'll talk about, where you're talking to somebody and you're bringing up on a particular time slot a talk group. Somebody else comes in and brings up the repeater with the talk group. I thought I turned that down. Apparently I didn't. They'll come in and they'll hijack the time slot. and all of a sudden you're talking to somebody and they're no longer there, you're not hearing anything because there's another time slot that's talking at the same time that you don't hear because your radio is not listening to all the activity. It's really more of an issue with DMR than any of the other digital voice modes, and we'll talk about that in a second. Hotspots, you are only limited by the control of the network that it restricts it to. You control the hotspot. It's your hotspot. You can hook it up to whatever network you want, and wherever you want to go, and wherever you want to do. In my mind, the hotspot is what I call amateur radio friendly. And by amateur radio friendly, and you'll hear me talk about that a lot tonight, amateur radio friendly in my book is that me having the radio in my hand and I want to talk to Jackson in a different spot on a different network, I control that. I set my radio and my hotspot up to be able to communicate, and it goes to Jackson, and there's no in between to prevent me from doing that. I call that ham radio friendly, amateur radio friendly. That's the way I think God intended it. The operator determines where he wants to go and how he wants to talk to. But as you're going to see later on, a lot of these networks are much less amateur radio friendly because they're controlled by people with the in-between steps in between to keep you from getting here or there or somewhere else. The negatives of the hotspots is, again, it's a small coverage area. You got to put this in your pocket. Every day when I walk in Central Park, I usually have a couple of these in my pocket. I have my radio on scanning different ones to be able to talk to different people that I can. But I control that, but I got to keep them nearby. If you get very far away, you can imagine these are low-power transmitter and receivers. You're not going to be able to communicate at all. But you control the connections. And you're the only user, so nobody else is going to come in and change it. For example, D-Star on a repeater, somebody wants it connected to a particular reflector, and you're on there and you're talking, and there's a lull in the conversation, and somebody else comes in and they decide, well, they're going to change it to a different reflector, and they get in and give the commands and change it to a different reflector. Now, you're no longer able to talk to whoever you want because the repeater is now connected to a different network, a different system. D-Star, we're going to go through each of these very quickly, one at a time. And again, this isn't because of time constraints. I can't tell you everything about all these different systems. Some are more complicated than others. I just want to get you a feel for what it is like and what it is and what the positives and negatives of each of these systems are. We could spend a 2-hour class or more on each of these systems. In DMR, we could probably spend weeks and years on the idiosyncrasies as it relates to DMR, as you'll see. D-Star is the oldest of the digital voice modes. It was the first system. It was created and maintained and used only. There's no commercial D-Star radios anywhere. It's only used by amateur radio. A lot of people don't like D-Star because they say, oh, that's old technology or whatever, and there's arguments to that. The biggest detriment to D-Star, in my mind, the biggest pain in the rear end is when Robin Crucial developed these reflectors, and in D-Star we call them reflectors. It's like a room of people that are all together in the same place, that are coming in on different, from hotspots, on repeaters and so forth, but it's a think of it, if you're a computer guy, think of it as a computer server somewhere in which you got all these computers that are all networked into a particular server, and that's where it is. And that's really what we're dealing with all these systems. So if you think of D-Star as a computer network, Robin Crucial came up with the idea, because before that, it was mainly used in Japan, and it used something called call sign routing to be able to communicate. And there's many pitfalls with the technology of call sign routing, and we're not going to get into it. But Robin Crucial developed this system called the D+ system, or the REF reflector system for D-Star. And basically what it did is it took the whole concept of this call sign routing away, and it created a system where basically there's this big computer server, or this big room, and people connect into it and can be able to talk to whoever they want all over the world. The negative about that is that they require, and they still do require, a registration process, which is a royal pain in the butt. It's a two-step process. You can go, and I have a website on here that you can check your registration. You log in, you create a registration, they send you an email back. Then when you get that email, then you got to go back and do a second step, and we're going to talk about that second step. That second step is where you got to create a terminal node, and you got to create a couple terminal nodes in order for the D plus reflector system to recognize and say, oh, Roger Smith, KY4RS, he's good to go, he can get in, but KN4COE, he's not registered, we're not going to let him into the network, okay? We're all hams, we all studied, right? You passed the test, you got a general, right? You should be able to key up your mic wherever you want to go and go. Do we have that kind of second hand or second check in the analog FM repeaters? No. Why do we need it with D-Star? I don't know. To me, it smells of control freaks, but that's just me. But anyway, we got this system. You can go and check. Here's a copy, and mine was changed because of the advent of all these systems that we're going to talk about tonight have advanced through the years. The technology has changed. The way D-Star was when I first got into D-Star is different than what D-Star is today. And so when they came out, ICOM came out with terminal nodes, and I bought my ICOM 705 radio and wanted to make sure I could use it in terminal modes. I had to go back and register again to be able to use terminal modes through a tier 3 ICOM system. And so that's why it looks newer than what I've actually been involved in D-Star longer than 2021. But you can see, here's my registration. You see my call, the date I was registered, the IP addresses, and I have 3 nodes that I have registered. The first one you want to do is your call sign with a space. That will pick up any of your radios that you have on. Then I also have AB4WS with a T for the terminal, and that's for the terminal node radios. And then I also have one Z, which is the last one. I actually have almost over 2 dozen hotspots. So I have hotspots that are identified on nodes from A through Z. Somebody has suggested that I have a problem. I disagree with them, but that's up for discussion. Craig? Well, it depends. You know, each one of them have batteries, and there's battery issues, and they get their power in different sources. They'll stay on the air. If you provide them with power, mine run 24/7. And again, it depends on your battery. I got some that'll last almost all day. I got some that the batteries are worn down and won't even last very long at all. That's what I got. The open spot 2s never have any power source on it, so that's why I buy these little cell phone batteries. I fix them with Velcro to the back of them. I keep them plugged in all the time, and then I plug a charger to it. And these batteries, I do research and find out which batteries I can maintain power, and they'll maintain power to the device the entire time.
Jack, what does the T situation do? Because that's one you know I haven't done yet. The other ones do not. The T one.
T is for terminal mode. That's what I have my 705 is you when you set up the 705 to be able to do terminal mode. Terminal mode is something that ICOM came up with. The 705, the 52, the newer versions of the 51 all do what's called terminal mode. The 4100, basically you don't use RF. It connects directly to an internet source and able to go out. And so you need to identify it as a node just like it would be a hotspot. And the node number is the letter T. Also in D-Star, and we're going to talk about that in a second, is that T is actually at the A spot. All of the commands of D-Star, and we'll talk about the commands here in a second, the last letter is in the 8th character spot. So there's like space, AB4WS space, the letter T for it. But the registration process, if you run into problems, get with me. There's a really good guy. He's the net control for the Kentucky D-Star net. He's down in Nancy, Kentucky, a guy by the name of Larry Jones, NN4H, and he has access to the database, and you can send him an email and he'll get you all set up for it if you run into problems. Just get with me and I'll facilitate that. D-Star has now 4 reflector networks, okay? Networks of computer systems that you can join or come into. The oldest one we talked about is the reflector D+, which are generally called the REF reflectors, and REF denotes the technology that's used to connect to, or for the reflector to communicate as well. One of the most popular D+ reflectors is REF 030 Charlie, and you can see, and we'll talk about what that title or name means here in a second. We also have XRF reflectors, which are somewhat newer. XRF reflectors do not require the control or the registration that D+ has. They're sort of an outlier. With D+ reflectors, you can't connect one reflector to another. With our XRF reflectors, you can have 2 XRF reflectors that can be connected to form an even bigger network. DCS, mostly European, and again, there's XRF is a technology used to communicate between reflectors, and DCS is a technology used to communicate between reflectors. But DCS reflectors, most of those are foreign, most of them in Europe. And the newest reflectors are XLX. In fact, some of the newer radios, like the ICOM THD75, will allow you to put in an XLX reflector. But many XLX reflectors that are multi-mode especially will have you use some other technology to connect to them. Specifically, and by multi-mode I mean an XLX reflector can be established to allow somebody with a Yaesu radio to talk into the network, a D-Star radio to talk into the network, a DMR radio to talk into the network, and sometimes even some analog modes like All-Star, Ham Shack Hotline, and other things will come into this great big computer server or communication server and allow those things. So if Mike has a Fusion radio and I'm on a D-Star radio and we're connected to the same reflector, I'm talking and transmitting on my D-Star radio in digital voice. It's going over my hotspot into the reflector. At the reflector, it's being transcoded to C4 FM and transmitted out to Mike, who's listening on a Yaesu Fusion radio. He keys up, he's transmitting in C4 FM, listening in C4 FM, I'm hearing his voice on D-Star, on D-Star. And that's what a multi-mode reflector is. I'm sorry, Steve?
Is that what you call cross mode?
Yes, yes. In other words, it can communicate across these digital voice modes. And those are. An example of one that's pretty effective that Larry, NN4H, and Ray, KY4RW, have set up is the XLX 721 Alpha, which is a Kentucky multi-mode reflector system, and it uses D-Star, but you can't use XLX 721 for the connection. You got to use DCS 721 Alpha to connect on the D-Star side. Then there's a Fusion YSF room that it connects to for Fusion radios, and a DMR talk group for Brandmeister to connect in. And anybody with a DMR radio, a Fusion radio, or a D-Star radio can transmit on their individual radios, on their individual voice system, and they can then be heard over each of those systems. And in many cases, you won't tell the difference whether somebody's on some other technology. The reflector label that we said we were going to talk about for D-Star is broken down into 3 sections. The first section is in this case, we're going to use REF 030 Charlie as the reflector that we're talking about. The first 3 letters refer to or identify the reflector network. which we just talked about, the REF, the XRF, the DCS, and the XLX. The second number is the actual reflector number. The third component of this, in this case the letter C, Charles, is always an alpha character, and for a D plus reflector, because they're the oldest system, is limited to 5, A through E. On the XLX, the XRF, and the DCS, it can go from A to Z for the node number, or the node letter. Generally, all of those reflectors, the letter E is the echo. So if you want to test your system and find out how it works, you can attach your radio, and I can demonstrate this later if we have time and you're interested, can connect up to, let's say, REF 056 echo, and then when I put the radio back into the talk command mode, I can key up and say AB4WS testing 1, 2, 3, unkey, and it'll say, I'll hear my own voice come back to me, and it'll say AB4WS testing 1, 2, 3. So you can test your audio, you can test whether you got the connection properly or anything else. There's 4 fields of data in programming the radio on a D-Star radio. The first one is called my call, and that's the operator's call sign. That's how one of the features of digital voice is there's some header data that's being transmitted that you do not hear that provides some basic information. And in D-Star, it transmits your call sign. In fact, if you're listening to D-Star, you'll see your call sign on many radios of the person that's transmitting scroll across the screen with a little message, maybe their GPS coordinates if they have that set up. The second field of data is the UR call field. And this is what I call the command field. This is how you're able to communicate with a repeater or a hotspot to be able to change reflectors or tell it where you want to go. So when you're talking, you need CQ, 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 those 6 letters in the UR call field. That's to be able for me to talk to Mike and Mike to talk back to me. If he doesn't have that in his radio, even though he's on the reflector, it will not go through the network. The second thing is, how do you link? So if I have let's say I'm on the WW4KY repeater, which is a D-Star repeater at the Northern Kentucky University by the WW4KY group. They're owned by AD4CC, David Schneider. And let's say that repeater is not linked. You do the I command and it says not linked. But I want to link it to 30 Charlie. I put my radio in the UR field. I put in the command REF 030C and L in the 8th character spot. L is the link. So I key the mic and immediately I'll hear the repeater say link to REF 030 Charlie. And the repeater is now linked. Now in order for me to talk on that now, I got to go back and change my UR field to CQ, CQ, CQ in order to talk. There is a whole bunch of commands that you can utilize within the D-Star world. The most popular ones is the letter U, and again, it's the letter U only in the 8th character spot. So you got space, 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 the letter U, that unlinks. So let's say the WW4KY repeater's on 30 Charlie and you want to change it to 56 Bravo. You would change your UR command to the letter U in the A spot, key the mic, you would hear the voice say, repeater not linked. Then you could put REF 056CL or BL, because we want it to 56 Bravo, key the mic and it would say, link to REF 056 Bravo. And then you would put CQ, CQ, CQ in the UR field to go back to talk. It's the command and control. To query the repeater to find out, let's say you jump in the car, you turn your radio on, you don't hear any activity, you want to see if WW4KY is linked to any reflector. You would put the letter I in the 8th character spot in the U field, key the mic, and it'll tell you where it is. It'll either say not linked if it's not linked to anything, or linked to so-and-so, or if it says linking to, which happens frequently, you'll hear it say linking to REF 056 Bravo. That means that something has disrupted the network connection. So you need to send the unlink command, resend the link command, it'll link back up, and then you'll be able to use it. Now, the two other fields of data that are important in D-Star is the RPT1 and the RPT2 fields. The RPT1 field is the call sign of the repeater with the node letter and the 8th character. The node letter for the repeater will be whether it's a 1.2 gig, a 440 megahertz, or a 2-meter repeater. If it's a 1.2 gig, it'll have the letter A as the node number. If it's a 440 machine, it'll have the letter B as in Bravo. And if it's a 2-meter, it'll have the letter C as in Charlie. Only if that's a repeater that you're communicating. Tom?
Where are you putting this in a computer or the radio?
On the radio. And it can be programmed in the computer in advance. It can be programmed. And we'll show you some screens about different radios. Okay. And every radio is different as to how it does. But we're going to show you a couple of them here in a bit. You can, yes. RPT1 field, so for WW4KY, in the RPT1 field, you put WW4KY space C as in Charles, since it's a 2-meter repeater. RPT2 is your gateway. If you don't have RPT2 field completed properly, and it should be WW4KY, or the call sign of the repeater that you're using with the letter G in the A spot, that's the gateway to get it out to the network. If you don't have that in, you will just be talking on the local repeater. You will not be heard outside. Sometimes on D-Star, people will be talking, you hear somebody and they're talking to themselves. You know, they're talking to somebody and then there's a whole bunch of dead air, and then they answer somebody again and you're not hearing the second person. 9 times out of 10, it's because that second person doesn't have his radio programmed properly. They're both talking on the same repeater, but one guy's going out through the gateway and the other guy is not because of that. Here's what we're talking about that Tom talked about, is where is it on your radio. Here's an ICOM ID 5100, and you can see the 4 fields of data on the screen. You got the UR field, which is CQ, 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 which means that's in the talking mode. In other words, I'm ready to carry on the conversation. RPT1 is WW4KY with the letter C in the A spot. WW4KYG is the RPT2 field. And then, of course, my call is AB4WS, and I've got the radio program because this radio allows a slash mark and 4 characters. And luckily, my first name is only got 4 characters, so I can put Jack. So every time I transmit across somebody else's radio, depending on the radio they have and what they're doing, will be AB4WS/Jack. And some people put the model of radio. There's no required methodology to what you put in that field. This is an ID 52. Again, in the DV mode, and again, there's differences in the types of radio. Some ICOM radios have a memory mode in which you can program the stuff in memory, so you could put channels for each one of those command modes in there. Or some of them have what's called a DV mode, which enables you to change those 4 fields of data. Again, each radio is different, and we could have a whole class on how to program each individual radio because the technology has changed through the years to be able to do that. This is an ID52 that's in DV mode, which enables you to do that. And in those radios, we can just use in the 2 field, the use reflector CQ, 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 and it'll automatically go out through the gateway, have the RPT1 and RPT2 fields filled out to you. This again is programmed on a hotspot. It's a DVAP, the older style DVAP that we have there. That's a frequency that's on, and that's the node P of my various list of hotspots. It also has the satellite information because it has a GPS built into it. In DV mode, we can go to reflector on the radio and then use reflector, and then you can program the radio ahead of time to have all the UR commands that you want in there. That's the way I do most of my D-Star radio, is I have the DV mode, the UR fields programmed with the list of reflectors that I use most often and the commands that I use most often. And for this case, you can see It starts out with CQ, 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 the letter I, the letter U, the letter E, and then starts on a list of reflectors to be able to change it to. Different radios and different models programmed differently. The G4KLX software, or the Pi-Star-based software of Pi-Star or W0CHP, the ones that look like this, require RPT1 and RPT2 fields for a hotspot. Again, that would be your call sign with a space, or how many ever spaces to have in the A slot. You pick a letter between A and Z. You want to stay away from the letter G because that's going to be your gateway. Stay away from the letter E because that's going to be an echo, probably. So any of those letters will do. So in this case, you can see this one here is letter Z for me. And within the software, when I set this hotspot up, I have it for AB4WS. Z is the node, and so in the radios that I'm communicating with this, when I do DV mode, I have an RPT1, AB4WS, space, the letter Z, and RPT2, AB4WS, space, the letter G. Also, the G4KLX Raspberry Pi based hotspots require an offset because they were originally designed to operate a repeater. But it's a simplex. So what you got to do is fool the software into thinking it's a repeater when you're really using it on simplex. So what you got to do is you got to, when you're programming the frequency in, you got to say this is a duplex, either plus or minus, it don't matter which, and then change the offset to a 0 megahertz, which essentially is simplex. But if you have it simplex, you won't be able to communicate. The Raspberry Pi based hotspot will not allow you to transmit the information out to the network. It has to be a plus or a minus with an offset of 0, and then it will work. And those are the two most problem issues that people have running Raspberry Pi hotspots, trying to get them set up originally. There's those two items. Open spots, which are made by RF Shark in Estonia, from version 1 all the way down to version 4, and this is a 4+, do not require RPT1 and RPT2 fields. They use a little bit different technology to utilize it, so they're a little bit easier to set up. However, with the Raspberry Pi based hotspots, if I want to change the reflector on this, I'll send the letter U command to it. It'll unlink, and then I'll send the command to link it to the new reflector that I want it to go to, and it'll link up. The open spots do not recognize the U command. You just go from one reflector to another, and it automatically disconnects you from the previous reflector and connects you up to the new one. So these are all idiosyncrasies based upon the device that you have, and you program your radio accordingly to accommodate each of those different ones. A repeater, again, has its own idiosyncrasies depending on the software and the hardware that the repeater's running and how the guy has it to set up. ICOM repeaters generally will not do anything but D+ reflectors. They won't do XLX or XRF or DCS unless they've went in and added some add-on software that's third-party to be able to facilitate that. WW4KY repeater at NKU is a hybrid hotspot-based repeater. So you can go wherever you want to go on any of the networks. The only thing David asks is that wherever you want to take it there. Just ask that you return it to 56 Bravo, went back, which is the Kentucky D-Star network, which the Kentucky D-Star net meets every Thursday night at 7 p.m. on REF 056 Bravo. DMR. Who's got DMR? Either love it or hate it. DMR is used by commercial radio. It's bastardized by amateur radio, where we used in ICOM, we used our call sign to communicate. There's no call sign in your DMR radio. You got a 7-digit DMR ID number that you got to get. DMR, one of the advantages is it's TDMA. time division multiple access. And you think, Jack, what the hell does that mean? That sounds like a whole lot of gobbledygook. Well, it is a whole lot of gobbledygook. To make it simple for you, you got to think, we all as amateur radio operators come up with this idea that everything's a frequency, right? The repeater, it's on 146.79, right? That's all we need to know, right? And the PL tone, right? And we can communicate. Well, DMR opens a whole nother bucket of worms, because with it being TDMA, it allows two people, Merle and Roger, to be transmitting on the same frequency to the same repeater at the same time, holding two different conversations, each oblivious to each other. One is on, Roger's on time slot 1, talking on one talk group, and Merle's on time slot 2, talking to somebody else on a different talk group. And each one are oblivious that the other one is there. Now that's a strength and that's a weakness. Strength is you got one frequency that's being able to be used twice at the same time, which automatically doubles the amount of potential use that we have for it. But there's lots of negatives about it as well. The radios that are available for DMR are either commercial radios or cheap Chinese radios. Everybody has an opinion. They're sort of like particular parts of our anatomy. We all have them. We all don't agree with each other's. In my opinion, the best DMR, easiest to program, the one that I like the best out of all the ones that I've seen are these Anytone 868, 878s. Chinese radio, they do a lot of stuff. Yeah, programming and everything is DMR's weak suit that we'll talk about here. Some people will argue that the DMR has better audio than any of the other modes, but it's sort of like women, right? If we all liked the same woman and was attracted to the same woman, there wouldn't be enough to go around. And obviously there isn't, because they left me out. The first thing you got to do, equal to the D-Star registration for DMR, is you got to obtain a DMR ID. It's a 7-digit number, and it's assigned by a group at radioid.net. Whoops, hit the wrong button. radioid.net. 7-digit number, and what that does is that links that 7-digit number to your call sign. Okay? Once you have that number, then that is linked into a database that takes and that links your call sign with that number. But that doesn't show up on your radio, because the database for those 7-digit IDs on a DMR radio gets programmed into the radio. The only information that's transmitted in the header information, like we had with D-Star, was your call sign. So the call sign on a D-Star radio would come across the screen. And a DMR radio, when somebody transmits, now this one here, you can see there's a net going on, and we have a call sign, WB8YYS in Kent, Ohio. It's coming over the repeater, right? But the only reason that is because I know 313983339, it's been programmed in this radio to say that's W8YYS. So a lot of times you hear somebody say, hey, there's something wrong with you. You got to change your radio because all I'm getting is a number. No, it's not your problem. It's the guy who has the radio's problem, because that's where the data is collected at the radio end. Because again, DMR was not an amateur radio system. It's a bastardized commercial radio system. It's originally designed for use in a factory, where you guys are working in factory, you're in maintenance, you're in production. You got a radio, they know what the ID radio is, and that radio only talks to people in production. You know, his radio only talks to people in maintenance. And so it's programmed that way to enable it. Amateur radio came in and says, hey, we're going to use this, and we're going to adopt it for our use. Again, the programming of a